Okay, hello there, Epidemics. I hope everybody's having a good week. Fresh from spring break, still feeling energized, not quite stressed yet. Give it another week and then we'll all be stressed again. Okay, so the assignments I posted over spring break are due on Friday this week. The quiz and the journal entry, I'm going to be posting new ones tomorrow, and those will be due Friday, March 31st before midnight. And the project will be due before midnight on Sunday, April 30th. If you have not yet submitted your topic and method of project for approval, those are due Sunday. Any questions on the project? I know we're starting to get down to the, well, I guess we've got another month before it's all due, but any questions on what we're doing with that? All right. In that case, let's get back to the plague. So last time we met, we talked a little bit about the various symptoms of the plague. We talked about the different forms of the plague. And we started talking about the formation of the buboes. So if you remember the buboes, those are those swellings that are classic for the bubonic plague. They start as a little blister and they get larger and swollen. They're often full of liquid, basically pus. And what's going on there is the bacteria move into lymph nodes. You've probably heard of lymph nodes before. If you think about it, if you've been sick, sometimes if you can feel a little swelling underneath the jawline, sometimes at the back of the neck, right under the base of the skull. These are lymph nodes that are swollen. In bubonic plague, they get much, much bigger than what we tend to see in the minor kinds of illnesses we tend to have today. A lymph node is part of the lymphatic system. And in simple terms, the lymphatic system has two major functions. It moves water from tissues into the bloodstream. So we tend to get more water coming out of the bloodstream in like our feet. You know, if you've ever had or known someone who's had swollen ankles or swollen feet, that's a common problem, especially with aging. And when we're younger, the lymphatic system works to help with that, to get that fluid out of the ankles, out of the tissues down there in our feet, and then it moves it back up through the legs and then back into the bloodstream. But the other thing it does is it's part of the immune system. So in the immune system, if we get material like bacteria or cancer cells moving through the lymphatic system, they get caught in lymph nodes. A lymph node is a swelling, and the interior of it is kind of like a sponge. So liquid goes through really easily, but things like bacteria or cancer cells get caught there. And we have immune cells in the lymph node that then act on that bacteria or that cancer cell. This is why if you have a cancer growth removed, they take the nearest lymph nodes They're looking to see if the cancer has started to spread. But anyway, the plague bacterium, Yersinia pestis, gets into those lymph nodes and it starts reproducing, and it causes, it's managing to avoid the immune system and what the immune system would normally do. So it's not being killed by the immune system. But as the bacteria numbers increase, the immune system tries to tackle the problem. And so we get lots of cells from the immune system. And the cells cause inflammation, which is an increase in fluids in the lymph nodes. So those lymph nodes swell up. They become incredibly painful because they're massive. It's like, imagine a golf ball tucked under your skin. That's not going to feel good. These are so painful that in England, in London, people would jump into the Thames or jump into other rivers or jump out of windows trying to escape the pain. It smells horrible too. And while medieval cities were not as filthy as we tend to think of it based on the movies, they still did not smell all that great. But then again, if you've ever been to Manhattan, you know that New York doesn't smell all that great either. But despite the fact that things tended to smell worse, these buboes smelled so bad that a lot of people could not work in the plague wards. They would literally start to feel sick trying to work in the plague wards. Without treatment, the bubonic plague has a mortality or case fatality rate between 30 and 90%. This is the mild form. And even so, 30 or more % of people who were infected would die from it. Death generally occurred within 10 days of symptoms. Okay, so we've got a very, very deadly disease. The bacteria causes high rates of death in the infected. Why? Why was plague so deadly compared to other diseases? So we're going to talk about a couple of things. And we're going to start with the bacteria itself. So these are two bacteria cells, obviously very simplified. Bacteria have a slightly different kind of DNA than our cells do. It's not in a nucleus, it's just floating in the cell. And it tends to form one very large circle. So if you took this chromosome and you stretched it out, it would be a big circle. But they can also have these smaller circles of genetic material that are called plasmids. Generally speaking, plasmids contain genes that help the bacteria survive, and whether that makes them more virulent, able to cause disease easier, able to multiply in the body easier, able to evade the immune system, also stuff like resistance to extreme temperatures and ability to eat new foods. So it's not always bad, but these plasmids can have virulence, I'm still spelling it wrong, virulence factors. These are genes that specifically help it to infect host cells. In plague, in Yersinia pestis, it has an enzyme that is coded for on the plasmid. So there's a gene for an enzyme on a plasmid that allows it to help avoid the immune system. So that's really one of the important things with plague that allow it to become deadlier. And with this particular enzyme in Yersinia pestis, the bacteria numbers, once they get high enough, they actually go after white blood cells. So they literally specifically invade cells of the immune system and try and destroy them. Now, what's going on this picture is something really strange. And we'll talk about this again when we talk about antibiotic resistance. Bacteria, the way they generally reproduce is they grow larger, they make a copy of their DNA, and they split into two. So they don't have recombination of genes through sexual reproduction like, animals do. But what they do have is they have a form of reproduction called conjugation, where they can exchange genetic materials between two different bacteria. So what happens is this cell has a plasmid that allows it to form a conjugation with another cell. So it forms this little bridge between the two cells. The plasmid gets copied and sent into the recipient bacteria. We can also have genetic exchange between a plasmid and the larger chromosome. So this way we get this new combinations of genetics. We get to exchange genetics between bacteria without sexual reproduction. So let's imagine this. I walk up to let me think, Viola Davis. We all know that she's a famous actress. She's an African-American actress. She is, in my opinion, one of the best actresses around right now. So I walk up to Viola Davis. I shake her hand. This forms a conjugation bridge. We exchange some genetic material. And the next movie she's in, she has naturally blonde, straight hair. Weird, right? But that's what's going on in these bacteria. They can literally change their genetics through this process of conjugation. Questions on this part? I know it's a new concept, probably.
All set.
All right, thank you. Now, survivors existed. It didn't kill everybody, but recovery was really long-term, and there would often be permanent damage to the body. Paralysis, deafness, blindness, and of course, psychological trauma. If you live in a community, plague comes through and wipes out, let's say 30% of the community, you're gonna have some serious PTSD. This is a modern day plague survivor. This young girl got plague, and thanks to modern medicine, you can see she's got a whole bunch of different IVs hooked up to the machine here. She managed to survive it. Communities that survived the plague would be resistant. They would have lower mortality rates. But when the Black Death was coming through, this was a virgin soil epidemic in Europe. The population had not been exposed before, and so you have a higher mortality rate. We kind of saw that with COVID, right? The first year or two had the first 2 years had a much higher case fatality rate than what we're seeing now. Many of the strains would vary in severity. So remember those genes on the plasmid? Some of the bacteria would not have as many virulence factors, so they might be milder. These are the ones that had the 30% death rate instead of 90% death rate. Exposure to milder strains offers some resistance to the more virulent strains. So the Black Death at the very beginning of the second plague pandemic was so deadly because it had a lot of virulence factors and it moved into areas that were virgin soil that had not had the plague before. Those two things combined to make it an incredibly deadly start to the second plague pandemic. So I mentioned a lot of these things before, but now let's start talking about our reservoir species and our vector species. So remember, reservoir species, we're talking about rodents. And this is a species that has the plague. It can be infected with the plague. Different rodent species have different mortality rates, but at least some of the species can survive at very high numbers. So it's not nearly as deadly in certain rodent species as it is in humans. And our vector is the flea. So humans do not get plague directly from the rodent. A flea has to bite an infected rodent and then bite a person. And that is how the bacteria gets into the human. So when we think about species that can be vectors, or I'm sorry, reservoir hosts, rats are going to turn out to be one of the major sources of plague in humans. So we're going to talk a little bit more about that in just a second. Rats are relatively resistant to dying from the plague. Nowadays, plague still exists. I've mentioned that a couple of times. And one of the species that can have the plague and not die off in large numbers are ground squirrels, specifically species that are native to the Southwest US. So plague is endemic in the ground squirrels in this area. The flea, however, does not do well with the plague. So the flea gets infected with the plague. It causes problems for the flea. The bacteria multiply in the digestive system of the flea. So it's staying in the digestive system in the flea, but it's multiplying and multiplying and multiplying. And eventually there's enough bacteria that it blocks the esophagus. That's the tube that we all swallow through. So the flea tries to feed, but it cannot swallow. And so it tries to get rid of the blockage in the throat by vomiting or regurgitating. And when it regurgitates, it's going to vomit up both the blood meal and some of the bacteria that are blocking the esophagus. That's how the bacteria get into the wound in the human. The flea is still hungry. It tries to feed again and again and again. So the bacteria is making the flea a more aggressive feeder. It's making the flea try and get a meal and bite more and more potential sources of food, be they rodents, be they people. Eventually, the flea dies of starvation or dehydration. We talked about the environmental changes that were going on in Asia in the few years before the Black Death. And we talked about the fact that these environmental changes can cause animals to move, including rodents. So during the time of the Black Death, there was a rat called the black rat, or scientifically Rattus rattus. I don't know why it did that. Sorry. And this black rat was what we call peridomestic. Peridomestic is a term for an organism that is very comfortable around people, that lives near human settlements or in human settlements. The black rat in particular was well on its way to becoming a domesticated species. It's an excellent climber. It's very flexible about lifestyles. And back during the Middle Ages, a lot of people would have black rats that lived in the walls of their house that would basically be pets. They would feed them, pet them, teach them tricks, but not, keep them in a cage or in an enclosure of any kind. So that's what we mean by peridomestic. We see this in modern times in some places with raccoons, not quite as far along the domestic scale, but they're very comfortable around people. We see them a lot. Some people feed them. You shouldn't do that. You see it with coyotes in some areas. Again, please don't feed coyotes. If you're feeding wild animals, you're getting closer in contact with wild animals. There's a higher risk of getting a zoonotic disease. Also a higher risk of getting bitten by one. So anyway, the black rat used to be the most widespread rat in Europe. Unfortunately for humans, the black rat was also an excellent carrier for plague. They had a lot of resistance to plague. And because they were so comfortable around people, they're bringing the plague right to the people. So the black rat was one of the black rat and its peridomestic status were really important for causing this epidemic, this pandemic. Nowadays, the most common rats around the world are brown rats, which is Rattus norvicus, or the Norwegian rat. It's not as good of a reservoir of plague, thank goodness. It's much more aggressive than the black rat, and it's not peridomestic. So you're not likely to see them, you know, sitting in your house looking at you going, hey, can I have a treat? Which is probably a nice thing. Okay, so that's the role of the two different species of rats. But as I said, the black rat was the most common one at the beginning of the Black Death. Now, plague does kill rats. Large numbers of dead rats being seen out in public places was a warning sign that an outbreak of plague was coming. So it would infect the rats first. Even though the rats had a better survival rate than humans, there were still a lot of dead rats. When a large percentage of the local rat population dies, then the fleas start biting people. So if there aren't rats around, fleas will detect body heat, carbon dioxide, that's what we exhale, vibrations, and so they will leave a dying body in search of a new host to infect. So we would often see a steep increase in fleas at the beginning of a new plague outbreak, and then we would see the plague outbreak. When humans died of the plague, anybody who helped prepare the body for burial were vulnerable to catching the fleas from the dead body. So the fleas would jump off the recently dead into the warm, moving people who were helping to prepare the body for burial. And back in the medieval time, this was usually family members. There are human specialist fleas. We don't think about that very often, but we do have fleas that are human specialists. The human specialist fleas can survive in clothing and bedding for up to 6 weeks between meals. So if the recently dead had human fleas on them, you take their clothing. Clothing and bedding were relatively scarce. Fabric was pretty expensive. So a lot of times clothing and bedding would get passed on to other people. Somebody dies, you take the clothes off of them, give it to somebody else in the family who needs a new outfit. Or you sell it. And the fleas go with the clothing, or at least some of them do. So that was another way that plague could spread between people. We didn't understand infection. And so a lot of people would leave the areas where there was a plague outbreak. And a lot of times they would end up in monasteries. Now, not only were monasteries at the time sanctuaries for people, they were also a major trade center. And so people would come to monasteries to buy and sell grain and other goods. So we've got people coming and going. We've got people fleeing to monasteries from plague areas, interacting with traders who are traveling through, and more spread of the plague. So I hope we're getting a good picture of all of the factors that came together that made the Black Death begin and that made it spread and become so deadly. Now, Yersinia pestis is a bacteria. Nowadays, we can treat bacteria with antibiotics. Antibiotics, the first one, penicillin, was developed in 1909, way too late for the second plague pandemic, but it helps now. Antibiotics work in a couple of different ways. So when we looked at our bacteria a couple of slides ago, it's kind of a round-shaped structure. But if we look closer, a lot of bacteria have multiple structures around the outside. So they have a cell membrane, just like our cells, but they have this other structure called a cell wall. And one of the ways bacteria works is by attacking that cell wall. Our cells don't have a cell wall, so the bacteria don't go after our cells. That's one way we can attack a bacteria. We can also stop reproduction, so we can prevent them from dividing and multiplying. We can also stop manufacturing proteins inside the bacteria. So those are the three major ways antibiotics work. Now, anything that's stopping protein synthesis in bacteria can have a similar effect in at least to some degree in our cells. So the way bacteria make proteins and the way our cells make proteins is closely enough related that we can sometimes have problems from that. And of course, we've probably all taken antibiotics and we probably all know about side effects. Generally, side effects are diarrhea, nausea, stomach cramps. These are not because the antibiotics are attacking us, it's because the antibiotics are attacking the bacteria in our digestive tract, the microbiome. So if you're not familiar with this, we have a lot of bacteria. Well, we have them everywhere in our bodies, on the skin and in our digestive tract. And in our digestive tract, they're very important for helping with digestion. There are certain foods we can't digest without specific bacteria in our gut. It helps with absorption of minerals. In fact, some of the vitamins and minerals that we use in our body come from the bacteria in our digestive tract. The bacteria manufacture them. So that's why we can have all these digestive issues with antibiotics. We also tend to see an increased risk of yeast or fungal infections. So these are yeast infections, but it's also things like jock itch and athlete's foot. So the rates of those tend to go up if you're on antibiotics. And in modern times, because we have overused antibiotics, both in our bodies and in farm animals in particular, that we're starting to see antibiotic resistance. Was there a question? Okay. We're starting to see antibiotic resistance, and antibiotic resistance is often on a plasmid. So remember, bacteria can exchange plasmids with other bacteria. And I didn't mention this before, but the bacteria don't even have to be the same species. So if you're infected with Yersinia pestis, and you're also infected with an antibiotic resistant strain of strep Strep can pass antibiotic resistance to Yersinia pestis. Talk about a double whammy there, right? Antibiotic resistance exists in bacteria for every single antibiotic that exists. So before we had antibiotics, bacteria were a major cause of death for humans. We're starting to see people die because they're infected with antibiotic resistant bacteria that are resistant to every single antibiotic out there. Fortunately, that's still rare, but it's something to be concerned about. Developing new antibiotics should be an important goal for our society, but it's a slow process. They're expensive to discover, to test, to develop, to make sure they're safe. And they're not very profitable because most of the bacteria that we get infected with are still resistant to certain antibiotics. So we can't charge a lot for new antibiotics. So expensive, long time, not very profitable. Governments are not funding research and development of new antibiotics. So companies, pharmaceutical companies, it's a high cost, low gain situation. Now, when a pharmaceutical or biotechnology company develops a new drug, they get 5 years of exclusivity, which means that for the first 5 years after it gets FDA approval, they're the only one who can sell it. This is so they can pay back the money it costs to develop that drug. So they get a profit for the exclusive profit for the first 5 years. That may not be a long enough time period for the developmental costs of antibiotics. Most drug development projects do not even reach the market. So most of them fail at some point along the pathway. And of course, pharmaceutical companies are not nonprofits. They're not doing it from the goodness of their heart. So they have a lot of pressure from the investors who own all the stock in the company to be profitable, not to save lives. That's not the goal of pharmaceutical companies, sadly. Their goal is to make money. In the US, I mentioned that it's still rare to die from antibiotic-resistant drugs. It's rare, but it's not unheard of. In the US, we have about 23,000 people who die from antibiotic-resistant bacteria every year. That's up there with the number of Americans that die from flu every year. So I want to talk a little bit about the pharmaceutical industry. So I'm going to go to the whiteboard here. So the average cost to develop a new drug. Developing a drug means getting it from, we've discovered this thing that works in cells, to going on the market. The average cost of that is $2.5 billion, not million, billion with a B. The time it takes from discovering a potential new drug, seeing something that works in the first tests to see if it's going to be functional to the market takes 6 to 7 years. Only about 12% of projects get to the market. So if we think about that, for every drug that gets to the market, there are 8 or 9 that fail. And those 8 or 9 might fail early in the process and only cost, I don't know, $500 million, or they might fail late in the process and still have cost $2 billion. So it's very, very expensive, and it's a long-term prospect. To develop a drug, you need a target. So we need to be figuring out what might be vulnerable. And since we're talking about bacteria, this is true for viruses as well. We have to have some basic understanding of how that bacteria functions or how that virus functions. So we need some basic research, some basic understanding of the disease. Basic research is usually done at universities. Big Pharma's not going, well, let's look at COVID and find a gene sequence and see if we can discover a target. No, that's done at universities, sometimes government institutions, but it is funded by governments. Your tax dollars at work. And funding is being cut. So the governments are not spending as much on research. So we really need a better way to figure out how to develop new antibiotics. What we're doing isn't really working very well, in part because governments aren't funding the basic research. Drug companies are not spending money to develop drugs because of the lack of profits. Now, on the other side of the scale, drugs are expensive. I mean, if you go out and you get penicillin, it's going to be cheap. But a lot of drugs are extremely expensive. And some of that is because they're expensive to make. Some of that is because we don't have good health insurance in this country. And some of that is greed. Look at the insulin prices. Insulin is expensive strictly because of greed. So what do we do? Do we have new regulations? Do we require healthcare to fund this? Do we fund development and research with government monies? Outside of the pharmaceutical industry? Do we limit profits of the pharmaceutical companies? And I think this is the topic of the day for our breakout groups. So we'll send you out into a couple of breakout groups and talk about what kinds of changes could be made or how you think we could improve the development, especially of things like antibiotics, which are not very profitable, as well as dealing with the high cost of drugs. Knowing that, let's be honest, if the pharmaceutical companies are not making a profit, they're not going to develop drugs. So We're going to send you into 2 breakout groups for 5 minutes. Okay, did you guys come up with the next great idea?
Well, it looks like there's a cap set to go in place January, not January, July 1st of this year to cap it off at $35 a month.
Good. That's good news. Anything else? Okay, I'm gonna have to start popping in the breakout rooms. All right. Okay, so the next little bit, a lot of the information that we're going to be talking about refers to later on during the second plague pandemic. So the Black Death itself was strictly the first 5 years of the second plague pandemic. But the second plague pandemic ran from the 1330s to the 1800s. We really consider 1347 to 1351 the Black Death. The 1330s, that was the plague starting in Asia. And let's not forget, the second plague pandemic was not the second one that hit humans. It was named that because at the time we didn't know about the Neolithic decline, which was really the first plague pandemic. So we didn't count that one because we didn't know about that one at the time. Okay. During the Black Death, just to remind you, around half the European population died, and about a third of the Middle Eastern population, the Islamic world. We know that the population of China declined dramatically during this time period, but we don't have great numbers. The data that we do have shows in 1200, an estimated 120 million people in China. And the next date we have a good estimate for is 1393. This is a relatively long time period. Estimated population, 65 million. So it looks like the population in China probably dropped by a good half, as well as in Europe. And again, as with almost every one of these diseases we talk about, I just cannot find good numbers in Africa. We think that at least the northern parts of Africa, Egypt, Morocco, and that sort of areas, we think those areas did get hit really hard, but we don't know for the rest of the continent, the sub-Saharan portion of the continent. there aren't a lot of scholars who have studied this time in African history. And as I've mentioned a couple of times, colonialism destroyed a lot of traces from this time period. So let's talk about what people during the Middle Ages thought was actually going on. What was their view of diseases? So generally, they thought diseases were caused by an imbalance of humors. So humors would get out of balance because of bad air. So miasma, this is the miasma theory. Miasma literally meant bad air. So something was in the air and it got our humors out of balance. Our humors were basically liquids in the human body. Blood, yellow bile, that's going to be from the gallbladder. Black bile, not sure what that was referring to. And phlegm, which we all know that's what comes out of our nasal passages when we are sick. They gave characteristics to each of these humors. And the characteristics would be hot or cold and dry or wet. So hot and wet was blood. Hot and dry was yellow bile. Dry and cold would be black bile. And cold and wet would be phlegm. They also associated the humors with the 4 basic elements: air, fire, earth, and water. Okay. Blood was associated with enthusiasm, with being active and social and attractive. Good-looking people had more blood than others. Yellow bile in excess produced aggression, short-tempered, but also daring, and yellow skin. So yellow skin could mean jaundice, but it could also be referring to people from Asia who have a little bit of a yellow tint to their skin. So at the time, this made sense because remember the Mongol hordes coming through, very aggressive, very daring. They would do lots of things that other people would be too inhibited to do. So it would make sense that they would have more yellow bile. Black bile in excess, depression, laziness, fearful and sickly. And these people would have black hair and black eyes. So we're talking about people of African descent or some of the darker complected people from the Middle East. So those people were depressed and lazy and sickly. Phlegm causes apathy, tumors, rheumatism, which is a type of arthritis where your joints swell. People with an excess of phlegm are low-spirited, not quite sure what they meant by that, forgetful, and had white hair. So when you get older, you're more likely to have an excess of phlegm. So you really wanted to kind of balance the humors. Even though blood sounds like a good one, you could still have it in excess. So to avoid getting the humors out of balance, it was important to avoid displays of emotions. So we want to be calm. We don't want to be too happy or too sad. We want to eat and drink sparingly. So no indulging in, no getting drunk, no eating a lot of food. But we also want to avoid excess exercise or sexual exertion. And we need to guard against sudden chills and drafts. That last one, you know, it still kind of sticks with us. We think that cold weather and drafty houses make you more likely to get sick, which not really. Plague itself was considered an excess of blood. So how do we treat an excess of blood? With bloodletting. Bloodletting could either involve leeches, or it could literally involve cutting the skin and letting blood come out. They also thought that emetics, things that would make you vomit, and purgatives, things that would cause diarrhea, would help get out any poison in the body from too much blood. Because blood is hot and wet, we want to encourage sweating. So using a lot of blankets and staying in hot temperatures should help you sweat out the disease. In addition, they would burst the buboes, so those swollen lymph nodes. They would cut them open, which would let out the excess humor. There's some blood involved, but it probably also helped relieve the pain of the buboes. It probably also helped reduce the number of bacteria. Not sure that it would reduce them enough to make a difference in the course of infection, but you know, we could hope. So that was kind of our basic understanding of what was going on at this time. Treatments were, as you can tell, not very effective. One of the most famous was Theriac famous panacea. So we've already talked about the word pandemic, meaning it happens everywhere. So panacea is a cure for everything. Anything that's wrong with you, this would cure. We still see this today. There are lots of people who are like, yes, if you consume nutmeg, it will cure your athlete's foot, your impotence, your cancer, your baldness, your lethargy, your low energy. We see this a lot with a lot of different herbs and vitamins because the government doesn't regulate how you advertise those very much. So, Theriac famous panacea, their idea of a drug. We start with opium. Then we add cinnamon, herbs. We pulverize those and mix with honey and the flesh of a snake. Then we ferment it. Let it age. Now, obviously, this is not going to do much for your health. It was hard to make. It took time. It took opium, which has never been cheap. You had to have the flesh of a snake, so that could be difficult to get hold of. This was available primarily to the wealthy, and it did nothing. None of these treatments did much. They didn't prolong life. They did very little to reduce suffering. The case fatality rate remained the same if you took the panacea, if you didn't, if you sweated it out under hot blankets, if you did bloodletting, all of that stuff. I mentioned bad air, the miasma theory of disease. So in some ways, this made a lot of sense because while we haven't really talked about malaria yet, malaria was a common illness during this time period all around the Mediterranean region. So the idea was that wet, smelly air, which you often find in swampy areas, which are havens for mosquitoes, that this air was the cause of the disease. We also thought that rats died first in plague because the miasma, the bad air, rose from the ground. So if you think about after a rain, especially if it's really hot, you can actually see the water turning into gaseous form. It's easy to see why that might be confused for bad air rising from the ground. And so when we think about miasma, as opposed to balancing the humors, if we're dealing with miasma, instead, we're going to fight that bad air. So how do we do that? We shut doors and windows. We hang heavy drapes and tapestries to block airflow. Now that probably makes it more pleasant in the wintertime, right? Because drafty houses, cold winters, yeah. So that did some good, but it also meant that you didn't have a lot of fresh air moving in. And almost every time in history, fresher air has been outside air. It's certainly the case today. If you want your house to have freshness, if you want fresh air in the house, open the windows. It's going to reduce a lot of those things that we don't want to be inhaling. Foul odors were suspected. Bad air, things that smell bad were in the air, which did lead to some changes. Things like cleaner streets and moving malodorous trades out of cities. Malodorous just means bad smelling. So if you're making leather, for example, that's a smelly process. If you're slaughtering and butchering livestock, that's a smelly process, especially if you don't get the parts that you're not using out of the city fast enough. So those things were moved out of the area. We start seeing the use of water to clean streets. Not so much because it's good at washing things away, which it is, but that relates back to baptisms. Baptisms use water. We're going to use water to clean the streets. We also start to see the use of aromatic agents. Modern day, this would be things like Febreze or those plug-in air perfume things. But back at this time, it would be bonfires. It would be gunpowder. Gunpowder was a relatively new discovery during the Middle Ages, and we had cannons pretty darn early. It really surprised me how early we started to have these things when I was looking this up. So they would fire cannons to get the smell of gunpowder. People would carry vials of aromatic spices or bouquets of fragrant flowers to carry pleasant scents with them. Later outbreaks, smoking, because that's going to help with the plague. But we thought smoking was producing good air as opposed to the bad air. Late in the second plague pandemic, not during the Black Death time period, we started seeing these plague doctors, and this mask had the beak attached to it so that you could fill it with aromatic herbs and spices. Again, we're trying to displace the bad air by pleasant smelling air. Okay, and we're close to out of time, so I don't want to get started on the next topic yet. Anybody have any thoughts, any questions, anything you want to discuss?
I just think that like what you said about the whole like hot air, like, you know, like earth, like black, whatever, it just really shows how like they were just totally wiped out. Like they had no understanding. Like people in the medieval, you know, ages, they had no understanding of science really at all. Like it was still so stuck in like superstition, kind of like that what they were doing that was like supposedly helping, like wasn't really helping like at all.
Yeah, that's certainly true with medicine. It wasn't all sciences though, and
Yeah.
the Middle Ages were not as ignorant as we like to think looking back, but absolutely disease,
Yeah.
we had no freaking clue what caused disease. Yeah.
Who came
Anyone
up?
else? Yeah.
Yeah. Who came up with that like cult theory, or like was that just a joint effort from everyone that like somewhat had an idea about it, like with the earth, air, and
The humors.
yeah, the humors? Like where did that come from exactly? Really?
I'm not sure if we know. It it was mentioned by some of the Greek philosophers, so it was probably originally from the ancient Greek. So it was mentioned by a lot of people like Aristotle, who were big thinkers and in, you know, trying to come up with ideas on what causes disease.
Okay.
I'm Googling it right now. It looks like Hippocrates is usually the one credited with applying this idea to medicine.
Okay. Okay.
Anything else? Okay, in that case, everybody have a good weekend, and I will see you next Tuesday.
Thank you too.
Thank
Thank
you.
you very much.
Bye.